These are the preview exercises for College Algebra Lesson 14. Last lesson, we discussed how to transform a parent function by shifting it up, down, left, and right. We're going to practice this skill on a new parent called f of x equals sine of x. So it's a wave function that you are probably not familiar with, but you will learn more about in a pre-calculus course. So I've given you a picture of the graph of sine x, this wave function. And on the same axes, I want to sketch a graph of g of x equals sine of x plus 2. So this plus 2 is outside of the function. It's outside of the sine function. It's not in the parentheses with the x. So that means it's a vertical change. And because it's addition, it's a translation, up or down. So this is going to be a shift up by 2 units. So I'm just going to choose some key points and shift them all up 2. So like this point right here, go up 2 and it lands here. And then this point here goes up 2, this one up 2, this one up 2, and then this max here goes up 2. And we're just picking a few key points and moving them all up 2 units. Here's one, and you go 1, 2, and it lands there. This one's at the origin, you go up 2, and it lands at 2. This one's at 1, you go up 2, you land at 3. Up 2, take this one and go up 2, and then this last one will go up 2 like that. And then we just connect these points with a nice smooth curve to make it match the shape of the one below it as best we can. We're not artists. Something like that. So we took the whole graph, shifted it up 2 units. In practice, the way you make that happen is you just choose some key points, move them all up 2 units. Okay, so for this next one, we want to sketch the graph of h of x, which is the sine of x plus 1.57. So this is an inside function change. So this plus 1.57 is in the parentheses. So it's a change to the input value, which means it is a horizontal transformation. Plus is a shift, left or right. And whenever you're doing inside changes, horizontal transformations, they always are sort of the opposite of what you would expect. So this plus you would expect means move right, but because it's inside the function, it actually means move left. So I'm going to take each point and move it left 1.57 units. So that means I'm going to start with this point right here that is at 1.57, and when I move it left, it'll be at the origin. So I'm actually moving everything left by 1 tick mark according to this scale. So this point right here, I'm going to move it left so it lands on the y-axis. So every key point is going to get moved left by 1 tick mark. Okay, so I'm going to mark the key points first, and then I'm going to move them left with a different color because it can be confusing to have all the same color. So I'm just marking key points, high points, low points, and sort of halfway between the high points and the low points. Okay, so each of those key points, I'm going to move left 1 grid mark because each grid mark is 1.57. So we've got here, here, here. So I'm just taking each orange point and moving it left 1.57. Okay, so all done. Now I just connect them with a smooth curve. Try to match the shape of the original because shifting shouldn't change the shape of the graph. And there we go. Whole graph shifted left by 1.57.